Hello, Chem 1A. This is Chapter 4, Lecture Video 1, and we're going to be talking about chemical reactions in this chapter. So chemical reactions are kind of the fun part of chemistry, in my personal opinion. These are the things that we get really interested in because chemical reactions produce new substances, and those substances can be very useful. For instance, the development of Kevlar or PVC or nylon. These were all products of a new chemical reaction that was being studied. And so primarily when we're concerned with chemical reactions, a lot of times we want to be able to predict what products we can get, as well as a number of other variables when we're discussing them. Now, in order to kind of symbolically show what's going on in a chemical reaction, we use something called chemical equations. Chemical equations pretty much tell us what's going on in a reaction, and we can kind of think of this as two parts. The reactants, the stuff that we started with, the before, versus the products, the after, the stuff that we end up with, what was made over the course of the reaction. And so we get like a symbolic representation of what's going on in our chemical change or reaction. So here's an example of a chemical reaction. Now, almost always there's going to be an arrow. This arrow separates the reactants from the products. The reactants are always on the left side of the reaction arrow, and the products are always on the right side of our reaction arrow. And this is kind of how we separate the before versus the after, right? The stuff that we start with, the reactants, are going to be on the left side again. And the stuff that is formed over the course of the chemical change or chemical reaction is the products, and that's going to always be on the right side of our arrow. We'll talk more about these numbers in front of our substances in probably the next lecture video. All right, so when we write a chemical reaction or a chemical equation for a chemical reaction, we could do it in terms of a sentence like this. Ethane gas reacts with oxygen gas to form carbon dioxide and water vapor. So there's some key important words here. Ethane gas reacts with oxygen gas. This tells me these two things are my reactants based on the word reacts. And then we're told they form carbon dioxide gas and water vapor. Based on the word form, carbon dioxide and water must be my products. Now we can write this chemical equation from the sentence. Something like this. Now again, the numbers in front of our substances, these are from what we call balancing our chemical equation, and we're going to discuss that in the next lecture video. But ethane we know is C2H6, and since we know it's in the gaseous state, we're going to put parentheses lowercase g next to it. Oxygen we know is a diatomic element, so it's O2 parentheses gas. Again, because we're told that's in the gaseous state. Carbon dioxide, we know from our naming system, is CO2, and it's also a gas because of the word gas here. And water, hopefully you know that water is H2O, and because of the word vapor, we know that it's also in the gaseous state. So notice that each one of my products and reactants has this parentheses with a symbol next to it, G in this case for gas. When we write our products and reactants out in a chemical equation, it's always very, very, very important to include the physical state of the substance. So we have different symbols to denote this. As we just talked about, gas is denoted with a lowercase g. When a substance is in the liquid state, it's in lowercase l. In the solid state, lowercase s, and in the aqueous state, lowercase aq. Now, aqueous is something we'll talk a lot more as we go over this chapter and the next chapter, but aqueous effectively means dissolved in water. In many reactions, we don't have substances in the same physical state. You might notice that in this first reaction we talked about, everything's a gas. But that doesn't have to be the case. A lot of times we have two substances that are in one physical state form a substance in a different physical state. For instance, here we have our reactant, sodium bicarbonate, in the solid state, forming sodium oxide, also in the solid state, and carbon dioxide gas, gaseous state, and water in the liquid state. So you can see here we have three different physical states in the same chemical reaction. This is totally feasible and happens often. All right, so if you have any questions, please let me know via email or come to office hours in Zoom.